Welcome, ladies and gentlemen. So what I'd like to do is show you how to simplify a algebraic equation raised to a higher power. So we're basically going from the cube root on up. Now, basically, the main important thing is when we're looking at this, we can use prime factorization. That means to write the number as a product of its prime, but also understand the identity element. Now, I only have square root and cube root, but obviously fourth root, fifth root, and sixth roots are going to follow the same process. And basically, that identity element is if you have the square root of a number multiplied by, or a variable multiplied by itself, that's just equal to x. We can rewrite that. X times x is x squared, so the square root of x squared is x. So the cube root of x times x times x is obviously just equal to x, or the cube root of x cubed is going to be x as well. So if we want to get into fourth root and fifth root, we're looking into multiplying that variable by itself 4 times, or having that variable raised to the fourth power. And therefore, the fourth root of x to the fourth power is just x. The fifth root of x to the fifth power is just x. So the index and the power are, or the root and the power are inverse operations. They undo each other. So obviously, I didn't even plan on having this, but the cube root of x cubed, you can obviously see that answer is just going to be x. The fourth root of x to the fourth power is just going to be x. That's just using that identity element. But now I have the cube root of x to the sixth power. And that doesn't work. So there's a couple different ways you can do this. And I'm going to kind of work through each and every way. I'm going to do prime factorization, the power rule, the product rule, and the power rule. So the first way is using prime factorization, basically rewriting x to the 6th as a product of its primes. Well, the prime variable would just be x. So I can rewrite this as the cube root. X to the 6th power means x times x times x times x times x times x. Right? Well, the cube root of x times x times x is just x. So I can break this up. So the cube root of x times x times x is just x. And the cube root of x times x times x is just x. So x times x is x squared. So the cube root of x to the 6th power is x squared. Now, that's not too bad, right? But we also have a problem. I don't want to write x to the 12th, x multiplied by itself 12 times. So I know that if I'm taking, this is the fourth root, right? So that means I'd have to group groups of 4. Well, I know that the cube root of x cubed is x. So that means the fourth root of x to the 4th is also x. So how many times could I write x to the 4th? Well, x to the 4th times x to the 4th is x to the 8th, because remember, the product rule says when you multiply exponents, you add the powers. Well, if I do it one more time, that gives me x to the 12th. These are equivalent expressions. X to the 12th is equal to x to the 4th times x to the 4th times x to the 4th. Because you add the powers, 4 plus 4 plus 4 is going to be 12. Well, I could separate this. I didn't show it separating that, but you can basically separate these. Or you could use them all under the same radical. It doesn't really matter. But again, that's another equivalent expression. And using this identity element, the square root of x squared is x. The cube root of x cubed is x. The fourth root of x to the 4th is just x. Fourth root of x to the 4th is just x. Fourth root of x to the 4th is just x. X times x times x is x cubed. OK? So we could use prime factorization, product rule. Or the last one is going to be the power rule. Now, we know that x to the 5th, the fifth root, we want to take the fifth root of x to the 5th power, right? And we could rewrite this as x to the 5th. How many times would we have to multiply x to the 5th to give me x to the 20th? We could do that 4 times. So I could write it out like x to the 5th multiplied by x to the 5th and do that 4 times. Or I could also say, I need this to be raised to the 5th power. But what do I need to raise to the 5th power that's going to give me 20? Well, remember, the product rule, the power rule of exponent says when you have an exponent raised to another power, you multiply the powers. So I know I need to take the 5th root of 5 because I had to take the cube root of 3 or the square root of 2. So I need to take the 5th root of 5. But what do I need to multiply 5 by to give me 20? Well, 5 times 4. So if we look at that, x to the 4th raised to the 5th is in reality the same thing as x to the 20th. But by writing it in this format, I know that the 5th root of 5 is just going to leave me with x to the 4th power. And you can see how for each problem, I didn't really break it up as much, but you can see how it's getting simpler and simpler by using the rules of exponents. So I'm going to primarily be using the product rule And I'm primarily going to be using the product rule and the power rule just because I don't want to write x multiplied by itself 28 times or 19 times or so forth. So over here, I'm going to use the product rule. I can rewrite this as the cube root of x cubed times x to the first power, right? Because you add the powers, and they give you x to the fourth. Well, the cube root of x cubed is just x. And then I have the cube root of x. Over here, you can see that the cube root does not evenly, or x cubed does not, 3 does not divide into 12. So I could rewrite this. Let's see. I could rewrite this as x cubed times x cubed times x cubed. Well, again, that's going to be, I guess I didn't even explain it over here, x cubed times x. So here I have 3, 6, 9. I need to get 2 more to give me 11, which would be x squared. I could break them up like I did here, or you can just use them under the radical. The cube root of x cubed is x. Cube root of x cubed is x. Cube root of x cubed is x. I can't take the cube root of x squared, so that remains there. X times x times x is x cubed times the cube root of 2. I'm sorry, x squared. I don't know where that squared came from. OK? So you could use the product rule like I did there and just kind of find out what else you need to get to that power. Or you could also use the product rule. So again, thinking about multiplying by 4. Well, 4 times a number does not give me 10. But I could do 4 times a number to give me 8, which is going to give me pretty close. So I'm sorry, 4 times 2, which gives me 8. So I could write this as x squared to the 4th, because x squared to the 4th gives me x to the 8th. That means all I need to do to multiply that is multiply that by x squared, and that's going to give me x to the 10th. Again, that gives you 2 times 4 is 8, so that's x to the 8th. X to the 8th times x squared is going to be add the powers, which gives you x to the 10th, which is there. However, now I can take the 4th root of x squared to the 4th, which is going to leave me x squared. The 4th root x squared is still going to remain under there. So that remains like that, and that is our final answer. OK. Same thing over here. I can do 5 raised to the 5th power is going to give me 25. So if I wrote this as 5th, x to the 5th raised to the 5th, that gives me x to the 25th. But I need to get to x to the 28th. So I need to multiply that by x cubed, because x to the 25th times x cubed is x to the 25 plus 3, which is 28. OK? You could separate it if you like to. The 5th root of x to the 5th to the 5th is just x to the 5th. I can't take the 5th root of x cubed, so that just remains underneath. And last but not least, I have the 4th root of x to the 19th. Again, using the power rule, I could raise 4, x to the 4th raised to the 4th, which gives me 16, which gets me pretty close. And that gives me 16, so therefore I need to multiply it by x cubed. Just like I did in the other problem, you can separate them, or you don't have to. The 4th root of x to the 4th is just x to the 4th. I can't take the 4th root of x cubed, so I just rewrite that as x cubed. So there you go, ladies and gentlemen. That is how you that's how you simplify a algebraic expression to a higher power and index. Thanks.